Hi, let's do some more math together. This is a video for grade 10s. We're looking at quadratic relations, some of the big picture questions. This is the question we're going to be doing in this video. It says, given the equation y equals 2x squared minus 12x plus 13, state all of the following and make a sketch. Okay, so I've been given a quadratic relation in standard form. And I need to state the vertex, the stretch factor, the direction of opening, the y-intercept, and the x-intercept, or intercepts. There might be two, there might be one, and actually there might be zero, so we'll see what happens. So first of all, I'm given the standard form equation. There's some stuff that I can do without doing any adjustments to my equation. And there's some stuff that I can't do until I do some algebra. So let's look at what we can do with a standard form equation. I can't find the vertex. That's why we have vertex form. So one thing I'm going to have to do in this video to answer this question is to rewrite this equation in vertex form. So let's just do that in a minute. What else can I do? Stretch factor. I can tell you the stretch factor because that's always the a value, and the a value doesn't change between standard form and vertex form. So it happens to be 2. Now it says positive 2. Even if it was negative 2, I would still write that the stretch factor is just 2 because it's just the amount of stretch. And it's not until I get to the next question, direction of opening, that I actually care whether or not I had positive 2 or negative 2. Well, I had positive 2, which means this is a positive parabola, which kind of looks like this, the letter U. It opens up. So this is a direction of opening up. Y-intercept. Y-intercept I can find in standard form. I can also find it in vertex form, but we might as well find it now and maybe we'll check what it is. So remember that no matter what type of relation or equation with x and y you're working with, the y-intercept is always found by letting x equal 0. So I'm going to let x equal 0 and calculate my intercept. And of course, hopefully you're already saying either out loud or in your head, why are you doing this calculation, Miss Townsend? Because if I let x equal 0, this is 0 squared times 2, which is just 0, minus 12 times 0. Well, that's minus 0. All that I'm left with is this number, which is positive 13. So I don't actually have to do that substitution and calculation because if x is 0, I'm left with y equals 13. So that tells me that my y-intercept, oops, hold on, bring that back. That tells me that my y-intercept is the point 0, 13. X-intercepts, we can't do that unless we have vertex form. So I've got some of the information, but I certainly can't sketch it yet. I don't know the vertex. It's going to be, I need the vertex to make a sketch. And also I can't answer the x-intercept question right now. So what I need to do is I need to rewrite that equation into vertex form. So let's go over here and maybe I'll adjust my pen slightly. It seems to be pretty thick for some reason. So I have y equals 2x squared minus 12x plus 13, and we want it to be in vertex form. So remember, this is what vertex form looks like. It's where we can literally see the vertex. So we've talked about a couple different approaches you can take. One of them is to calculate the x-coordinate of the vertex by doing this calculation. If you do this calculation using the a and b values, then that will tell you the first number of your vertex, and then you can calculate the second number. Totally fine. I actually like the other method better. I'm going to do this by completing the square. So the first thing I notice is that the x squared is not in simple form. So I have a number other than 1 multiplied to x squared, and I don't want that. So what I'm going to do is I'm going to remove that temporarily by dividing everything by 2. So y divided by 2 equals x squared, because I divided by 2, minus 6x, because I divided by 2, and then plus 13 over 2. So you'll notice here, hold on, let me make sure that stuff's on the side, that I've left quite a space. And I've left that space on purpose because now I can think about actually doing what's called completing the square. This is where I try to create a perfect square trinomial out of 1, 2, 3 terms. I've already got the first two. I need to figure out what the third piece would be to create a perfect square trinomial. And of course, a perfect square trinomial is the thing that we get whenever we have a binomial squared. So what we have to do is we have to look at this number in front of x, which is negative 6. We need to take half of that number, brain bubble over here. Negative 6, half of that is negative 3. And then whatever I get, that half number, I'm now going to square it. So I get 9. And that tells me that I need to add 9 to create a perfect square trinomial. But of course, I can't just walk up to this quadratic relation and add 9 because I'll be changing it. So therefore, I'm also going to subtract 9 because technically what I've done is I've added 0. But I've added 0 in a very special way. What I've done is I've created these 3 terms are a perfect square trinomial, and then I have the leftover bits, which I'll worry about later. So now I'm going to rewrite that perfect square trinomial as a binomial squared. We know that if we square a binomial, we always get a perfect square trinomial. So this is just going backwards. So I know I need x here. And then remember that half number when I said take negative 6 and divide by 2? That number was negative 3, and that's what goes here. And we can really quickly pause and make sure it works. If I square the first, I get x squared. If I double the product, I get negative 6x. And if I square the last, I get 9. So that is the same value. So now that I have my beautiful, oops, oh, I'll go a green pen. Now that I have my, one second, technical issue. I lost my work. Here it is. I don't edit my videos. I don't have time for that. So that was just fun for everybody. Here we were. I had just completed the square and then rewritten that perfect square trinomial as a binomial squared. Now I can multiply by 2 again. So let's return to just y equals and get that 2 back in business. So I'm going to now multiply everything by 2. So y equals 2 times that bracket. So that's multiplying that by 2. And then I'm going to multiply negative 9 by 2. And then I'm going to multiply 13 over 2 by 2. And of course, this 2 just cancels that 2. So I'm left with 13. So all that's left to do is to collect these terms. I have negative 18 plus 13. So negative 18 plus 13 is negative 5. So now I have the vertex form of my quadratic relation. So now, if we go back to what we were doing, so actually I'm going to, I don't know if I can remember how to do this on this. I'm going to see if I can take this with us. Nope, I'm just going to have to remember what it is. Y equals 2. Okay, so, not you. Okay, so let me just rewrite that here. Y equals 2x minus 3 squared minus 5. That was what we discovered was the quadratic relation in vertex form. Now I can tell you the vertex. The vertex is positive 3, negative 5. So remember that positive 3 is because 3 substituted for x makes the bracket 0. So what a lot of students remember is that it's the same number that I see in the bracket, but the opposite sign. And then the negative 5 is just literally what's written right there. So that is the vertex. So how are we going to find the x-intercepts? Well, there's two approaches here, depending on how much algebra you want to do and how perfect you want your answers to be. So let's start with the simpler method, which is where we may not see perfect answers, and we'll just have to live with that. So, and that means we're going to make the sketch and just look at our sketch and guess or estimate if we don't have nice lattice points. So I am now going to sketch with you the parabola that has a vertex at 3, -5, put a nice dot, and then the stretch factor is 2, and I go up. So instead of going over 1, up 1, and over 2, up 4, and over 3, up 9, hopefully this is something you're just doing in your head. We know that these are actually stretched, so I would go over 1, up 2, over 2, up 8, and over 3, up 18. So from the vertex, over 1, up 2, and I do that in both directions, over 2, and up 8. So from the vertex, I'm going to count over 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just, maybe you can see my little dots there, just because I wanted to show, I don't know if you can see my cursor. And then I can mirror that point in the other direction. And I'm not going to have space to show over 3, up 9, so I won't. So this is very, I can do better than that. I mean, it's hard to draw with this writing tablet, but at least I can try to touch the vertex. There we go. There we go. What a terribly horrible looking parabola. But nonetheless, there's my parabola. So definitely with my sketch, if I use my sketch to try to find my x-intercepts, I'm really going to be estimating. There's one about here and there's one about here. So I would say that one of them is 1.50. So I'm thinking that's about halfway between 1 and 2. And the other one is 4.5, because that looks to be about halfway between 4 and 5. But, I mean, consider how terrible my graph looks. Those are just estimates. Let's talk about how you would do it without estimation, the algebraic approach. So in order to find the x-intercepts algebraically, we need the vertex form of the quadratic, which is this. And then to find an x-intercept, we need to let, oops, not x. I said x, so my brain wrote x. We need to let y equals 0 and then solve for x. Because an x-intercept is on the x-axis, which means you haven't moved up or down. So there's no verticality. Y is 0. So I let y equals 0, and now I need to solve. So my x is buried inside this bracket with a squared sign, and there's a multiply by 2. So I have to undo the math in order to get x isolated. So the first thing I'm going to undo is the -5. So that means I'm going to add 5 to both sides. Now I need to get rid of the 2. So I'm going to divide both sides by 2. And now we have a fraction. And my next step is going to be to take the square root. And most square roots are going to be weird decimals. So I might as well make this a decimal now, because why not? We know we're going to get decimals anyway. So I've changed 5 over 2 to be 2.5. Now I need to take the square root of both sides, because that's how you get rid of square. So the square root of 2.5 is equal to x minus 3. I don't need the bracket anymore because I've taken care of the squared, but I do need to remember that when I take the square root, in other words, I'm undoing a square operation, that there's actually two different answers. There's a positive version and a negative version. So I'm just going to calculate what that is. The square root of 2.5 is approximately, boop, beep, boop, 1.6. So we're going to say plus or minus 1.6 equals x minus 3. So what that really means, what the plus or minus does, is it means that I actually have to work on two different equations now. One of them is the positive version that says positive 1.6 equals x minus 3. And the other is the negative version. And now that's how I'm going to get my two x-intercepts that I saw when I graphed it. So here, I'm almost done. I have x minus 3, so I'm just going to add 3. I get 4.6 equals x. Here, I'm going to add 3, and I get 1.4 equals x. So my x-intercepts, and these aren't exact either because I used a calculator and I rounded. So, my actual estimates that I did from my graph, I think I had 4.5 and 1.5. I mean, it wasn't that far off. So because we rounded anyway, it wasn't a great, my graph was actually pretty good. But that is another way to find the x-intercepts, and that's something we'll continue working on. So I hope that was helpful. Keep practicing.